Variations on a theme, SQL edition, SQL. We're going to have a look at the theme lead and lag and how this can be useful in order to solve certain problems pertaining to influx and outflux in certain data. And we're going to have a look at 3 problems, and then going to have a look at the theme and see how we can vary that theme in order to solve those 3 problems. So without further ado, let's go to the first problem. LeetCode 601, human traffic of stadium. X city built a new stadium. Each day, many people visit it, and the stats are saved in these columns: ID, visit date, people. Please write a query to display the records, which have 3 or more consecutive rows, and the amount of people more than 100 inclusive. For example, the table stadium, ID 1 through 8, visit date 2017 January 1st through 8th, and then people ranging from 10 all the way to 1455. For the sample data above, the output is ID 5, visit date 5, people 145, 6, 1445, 7, 199, and 8, 188. So that's basically the amount of people who have more than 100 people, and all those people basically have to be put up. Next up, consecutive numbers. Write a SQL query to find all numbers that appear at least 3 times consecutively. ID 1 through 7, number 1, 1, 1, 2, 1, 2, 2. For example, given the above logs table, 1 is the only number that appears consecutively for at least 3 times. You see it here, consecutive numbers 1. Then the third problem. 6 to 6, exchange seats, flagged as medium. Mary is a teacher in a middle school, and she has a table seat storing students and their corresponding seat IDs. The column ID is continuous increment. Mary wants to change seats for the adjacent students. Can you write a SQL query to output the result for Mary? ID student. ID 1, 2, 3, 4, 5, student Abbott, Doris, Emerson, Green, James. For the sample output, or for the sample input rather, the output is 1, 2, 3, 4, 5, Doris, Abbott, Green, Emerson, and James or James. If the number of students is odd, then there is no need to change the last one's seat. So basically what we see here, Doris and Abbott have switched seats, Green and Emerson have switched seats, and James or James stays at the same seat because there's like no more following student. What we can see specifically from here, it's really more about what happens between the current row and between the next row. And that is basically the main theme in order to tackle those problems, and it's called lag and lead. It's provided today by mssqltips.com, SQL Server tutorial. This one has been written by Koen Verbeek, and in this tutorial he basically just really describes the idea of lag and lead and how it's going to be used in the syntax, and then with a concrete example, and goes through it line by line. So let's have a look at the definition. The lag function has the ability to fetch data from the previous row. The lead fetches data from the subsequent row. That's all the magic to it. So given any current row, look at the predecessor row. And given a current row, look at the successor row, which comes in handy if you want to have like scenarios like calendar dates that are subsequent, but not really. Maybe you're missing a date or something, so you can't really just tackle it by number +1 or -1 and hope that you kind of fetch the next element. Instead, it's rather more efficient to just like look above in the table and look below in the table and see what is in there. For example, also it might happen that items in the table get removed, so there's like no consecutiveness that you can enforce by an iterator. So it's really best to use lag and bleed in these scenarios. Syntax goes like select from, and then here we have this lag something 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 equals lag of what you want to query over order by. We can see that for each year, the data of the previous year has been fetched in the second column. So this is basically what's been achieved here. Sales amount previous year is going to be fetched from sales amount, and then you look one row above. Like that's basically the whole idea. You look over sales amount, and you put it into sales amount previous year. That's the lag. And the same basically holds for lead. Lead just looks into the next row. Like lead function has the following two optional parameters: offset, default is 1, but you can jump also by a larger offset. You cannot specify a negative value, rather just switch lead with lag. The default value, when there is no previous row, null is returned. So if you are at the top, return null. You can specify a default value to be returned instead of null. If you would sort descending, the window function lag will fetch the next row's value instead of the previous one. And then he goes into like more and more details that are helpful in the scenario of lead and lag, which go into more and more detail, but for the context in which we want to solve those three problems, we basically just have to keep in mind we want to solve a problem where a count row is dependent on the previous or next row, and in that scenario we call lag and bleed. Where did we start? We started with this one, human traffic off stadium. That's from human traffic off stadium solution using lead and lag 660 milliseconds. Since we only have one table, no alias ID is required for the subtable. This problem is more like an introduction to lead and lag variable period. So how does he do it here? Select ID substring visit date people, from, and then select ID visit date people, lead people 2 over order by ID s, and then he specifies a variable u2, lead people 1 over order ID as u1, and then lag people 1 over order ID as L1, lag people 2 over order ID as L2. And then basically all he needs to do is just check if we are in the range and if we have this occurrence of more than 3 consecutive people. This is basically what is querying down here. If people more than 300 and u2 greater or equal than 100 and u1 greater or equal than 100, or u1 greater or equal than 100 and L1 greater or equal than 100, or L1 greater or equal than 100 and L2 greater or equal than 100. So he looks at the consecutive 2 rows and he looks at the previous 2 rows in order to get this scenario where you have like 3 consecutive rows that fulfill the requirement, and people have to be greater or equal than 100. Anything less than 100 is discarded just using this inequality. Next up is consecutive numbers. Lead and lag functions accept a solution with XS. Select ID lead num10 over order by ID ascending lead. So here we have lead in the next row, and lag previous row, num10 over order by ID ascending lag from the logs file. Select distinct num as consecutive nums from logs L, join XY on. If LID equals YID and Y lead equals LNum and Y lag equals LNum. So basically here we just make sure that we have the occurrence of the same number, and lead and lag basically really just give us if we have this number in the row above or in the row below. This is the key thing that we want to query here. So that's basically really how we apply our theme of lead and lag here to solve those functions where it's about consecutive rows. Last up is let's change seats, the students, right? So the teacher wanted to change the students. It's a bit slower than the other solution that uses max. This solution takes advantage of lead and lag window functions. So what is it doing here? We are ignoring those special functions for the moment, but rather just straight go into those scenarios here. He does a modulo in order to find out if we are like the first or the second student in a pairing that we need to switch, right? Remember, you always switch like the zeros on first, and then second and third, fourth and fifth, and then if you have like a 6 and no 7s, or like a zeros and no 1, then this one just zeros and firsts, then this one just stays as it is. So you check for the pairings, which is what you do here with the modulo number, and then if you have a pairing, then you check at the consecutive row and the next row if you are the number 1, and if you are the number 0, then you look into the previous row. Over order by ID, so you make sure that you order it correctly. Otherwise, you don't do anything, right? Otherwise, if you can't do this modulo change in order to find like the next student, then you just leave it as is. And that's basically the whole magic to it. Find your number within the modulo, and then if it's one number, then go to the next row, and if it's the other number, go to the previous row, which is basically just like spelling out what has been verbalized in the text anyway. So it's like taking the text and putting it into logic using our theme of lead and lag.